Hi everyone, this is Divyang Khandelwal from DivVision Math Academy. In the previous video, we discussed about area and perimeter. In this video, we are going to discuss about surface area and volume, or basically we are going to talk about 3D shapes. Remember, I'm going to give you one tip which will be very much useful throughout your academics with respect to surface area and volume, so that you won't avoid any silly mistake, which I have already mentioned in the previous video. So anyways, we'll start with this thing called surface area and volume. So first of all, let's discuss about surface area and volume. What does it mean? Now, surface area means what? So if I have a 3D shape like this, so I'll just draw one cuboid. So surface area means what? The amount of paper required to wrap this box. So efficiently. So basically, if I have some paper and which I want to just stick there just to close that box. So the amount of paper which is required is basically surface area, and the amount of air which is there in this shape, that is basically volume. Now remember, surface area is area. That's why the unit is going to be meter square. Volume means the amount of air which is there inside. So it's going to be in meter cube. Why I'm telling you all this? If you have watched the previous video, you must be knowing why this tip is very essential. That's what I'm going to tell you. So anyways, we'll start with this thing first, which is cuboid. Now remember one thing. First, we will talk about surface area, and then we'll talk about volume. Now, if this is the shape and we have length, width and height of this cuboid. Now, what is going to be surface area? So as you can see, it is divided into 6 parts. Like, this is the front side. So we'll say this is front view, front side. This is the back side, which is at the back, like this from behind. This is at front. Then there is this side, which is left hand side. Then here, this is right hand side. And here we'll mention this thing as top side. And this is base, we will say. Always remember, I'm focusing a lot on this base because we're going to use it a lot. So that's why this is base, left hand side, right hand side, top side, front view and back view. Now, as I told you, area means what? Surface area means what? How much paper or how much page do we require to cover that complete box? Now, it is based on 6 rectangles. So we'll talk about the front view or the front one, then the behind one or back one. So as you can see, the length of the front one is this part, and this portion is basically the height of this thing. So as you can see, the area of the front is going to be left L into H, and for the back is going to be again L into H. If we talk about left hand side and right hand side, as you can see, it's a triangle, it's a rectangle like this, and these two rectangles are also same. Okay. Now, the area of the left hand side, again, this is going to be width and this is going to be height. It's going to be LHS I'll take, and RHS is going to be what? It's going to be width into height. Now, if you talk about the top surface and the base, like I'm talking about this region and this region, both are same, of course. And if you see the top and the bottom or base, the area is going to be what? It's going to be length into width. So if you see the total surface area is going to be what? It's going to be L into H plus L into H, then plus width into height, plus width into height, plus length into width, plus length into width. So if you see, if you combine all these things, it's going to be what? It's going to be 2LH plus twice WH plus twice LW, which if we take out common 2, so we'll get LH plus WH plus LW. In short, what you have to do, you just have to multiply L with W, W with H, H with L again, and then you just have to add it, and then you have to multiply by 2. That's gonna be the surface area of cuboid. If you talk about lateral surface area means what? Whatever you can see, or if you walk around, then how much, like whatever the surfaces you are gonna go through, that's basically lateral surface area. So if you're standing here, like for example, and you're moving, so you will be moving like this around this thing, and that whatever surfaces it's gonna cover, so that's gonna be lateral surface area. And for that, we are gonna cover only 4 sides: left hand side, right hand side, front and the back side. So it's going to be what? It's going to be length into height, twice of course, because front and back. And LHS, RHS is going to be width into height plus 2 times width into height. So that's all lateral surface area. So anyways, and if you talk about volume, volume is always easier. Volume is going to be what? Volume is going to be, always remember, volume is area times height. Practically, if you see that if I have this shape like this, and if I have a object of this shape, for example, and it has a height of this much. So whatever this shape is, how much volume it will be there? It's going to be area times height. So volume is always area times height. So for this thing, volume is going to be what? Area of the base is going to be how much? That's why I told you that concentrate on base. So base is going to be length into width. So it's going to be length into width into height, or basically just multiply all the three, length, width, height, you will get the volume. So that is your volume of cuboid. Now for cube, it's going to be very simple. For cube, it's quite simple. So volume is going to be what? Volume is going to be, see, all the sides of a cuboid, if they are same, then it becomes a cube. So here it's going to be what? It's going to be, volume is going to be what? It's going to be S into S into S. Let's say if S is the side length, so it's going to be S cube. And if you talk about surface area is going to be 2 times S square plus S square plus S square, because all the sides are equal, which will eventually give me 3S square into 2, which is 6S square. That's your surface area of a cube. Okay. Now, why this is important? Because whenever we talk about volume, we generally say the volume of this room is maybe 10 meter cube, for example. That means what? Just like in area, if I say 10 meter square, then 10 squares of 1 by 1 each will be filled in that, on that surface. But if you talk about volume, then if it is 10 meter cube, that means 10 squares of 1 by 1 by 1 each, like this. If this is a cube of 1 meter by 1 meter by 1 meter, so you can imagine 1 meter by 1 meter means what you can do, maybe half of your height, not half, somewhat 3/4 of your height, or you can say 100 centimeters, so maybe till chest or something like that. That's basically 1. So 1 by 1 by 1, that's gonna be the 1 meter cube. So these many boxes will be filled in that particular region or particular room. That's basically 10 meter cube. Okay, so the volume will always be in meter cube. I'll tell you the tip later about meter cube and all these things after we complete all the shapes. Now the third one is simple, which is cylinder. Now again, if you draw the cylinder, okay, like this, and they have given some things, that is radius of the cylinder or the base of the cylinder, then they will give you height of this thing. Now remember again surface area and volume. Now see how much amount do we require to fill this thing first of all. So volume is very simple. Volume is what? As I told you, it's area times height. So what is area? Area is a circle, right? It's a circle at the end. If you see at this position, it's a circle. Like from the top view or the top view or from the base, if you see, that's gonna be circle, whose area is what? It's gonna be pi r square. So radius is this much, so pi r square, that's gonna be the area. Height is how much? Height is they have given, so pi r square h is the volume of the cylinder. So base into height, again, that will give you volume. What about surface area? So surface area is going to be how much? Now see, if you open this cylinder, it will be somewhat like this. Again, I told you that no need to learn the formula. You just have to remember it. I'm just making this circle small because it's not, the page is getting over, that's why. But the circles are same, okay? So now the radius is r. So as you can see, if I open this cylinder, it will be a rectangle whose height is going to be this much. And if you talk about this length is how much? So as you can see, it's the outer part of this circle, like this. And that is what? That is actually the circumference of the circle. So this is going to be 2 pi r, We know that the circumference of a circle is 2 pi r. If you don't know, go and watch the previous video. So anyways, it's going to be 2 pi r and h is going to be the height. Now, if you see, the area of this rectangle is going to be how much? It's going to be 2 pi r h. So surface area is going to be two circles, area of two circles, which is pi r square plus pi r square. That is nothing but pi r square plus pi r square. Those are two circles. I'm talking about this circle and this circle. And the area of this rectangle is going to be what? It's going to be plus 2 pi r h. So if you see, this is nothing but 2 pi r square plus 2 pi r h. You can take out 2 pi r common and you will get r plus h. Again, I'm telling you, don't remember this formula. This formula basically. Use this formula, 2 pi r square plus 2 pi r h. Then you can take one more step to make it like this. Okay. No need to learn the formula. Just use logic. Okay. Now this is basically cylinder. Now we are gonna talk about, I forgot one thing, lateral surface area. I generally forget because you can apply logic for this thing. Lateral surface area, again, I'm standing here and I'm going like this. So basically I'm talking about this area, which is nothing but 2 pi r h. That's going to be the lateral surface area. Okay. Now let's talk about the fourth shape, which is nothing but a cone. Remember, cone is just 1/3 of a cylinder. Okay. Now for that thing, we require certain things. Let's say this is the cone. They will give you radius. And there is one more term, which is slant height. By the way, just consider this 2 pi r h as very important. I'll tell you later. Now, this is the slant height, this is radius, and this is the height. Okay, so this is the height of the cone. So they have given you this much amount of things. Now, what is going to be volume? Volume is 1/3 of volume of cylinder. Just remember like that. And we know that volume of cylinder is pi r square h. So volume is going to be 1/3 of pi r square h. Okay. Now, what about surface area? So if you talk about surface area, you can see the base area is going to be pi r square. Okay. But if you talk about this, like this portion, I'm talking about this cone. So as I told you, So as I told you that this is quite important. Which one? This lateral surface area of a cylinder. Now, of course, the surface area, the total surface area is going to be pi r square plus lateral surface area. Again, I'm telling you, if I'm standing here, I'll have to come around like this. So I'm talking about this region, the cone region, this one. So lateral surface area is going to be how much? So in cylinder, it is 2 pi r h. Here, it's going to be pi r l instead of h. Okay, we have to give some amount of importance to this L as well. That's why it's going to be pi r L. So remember, it's going to be pi r square plus pi r L. So the total surface area is going to be pi r square plus pi r L. But if you talk about lateral surface area is only going to be pi r L. Okay. Now, so this is what about cone is. Now see, for the cone, it's going to be a little tricky. So that's why total surface area, you just have to remember it's area of the circle plus lateral surface area, which is pi r L. So in cylinder, it was pi r h. Here it is pi r L. In cylinder, it was circumference into height. Here it is pi radius into slant height. The slant height is important here. In case, if they don't give you slant height and they give you only height and radius, then what we will do, we will just use Pythagoras theorem. So basically, if you can see, if I mention this thing as A, this is B and this is C. So in triangle ABC, you can use L is the hypotenuse. So that's why L square is equals to R square plus H square. You can use this formula to determine the slant height or radius or even height, whatever they ask. So that's how you'll have to use. Now, finally, we'll talk about the last shape, that is sphere. Now, if we talk about sphere, so of course it looks like a circle only. Volume is going to be what? It's going to be 4 by 3 pi r cube, and surface area is going to be 4 times area of circle, that is pi r square. Remember, this is nothing but area of circle. So volume is going to be 4 by 3 pi r cube, and surface area is going to be 4 times pi r square. Now, how to remember this thing? So one pro tip for every shape. First, let's revise all the things. Then I'm going to tell you about that pro tip. Now, first of all, we are talking about surface area and volume. So if we talk about cuboid, I won't take cube because cube is just a part of cuboid. So it's going to be what? It's going to be volume is going to be length into width into height. Surface area is going to be 2 times LW plus WH plus LH. Okay. If we talk about then we had to talk about cylinder, right? Then cylinder is going to be what? So volume is going to be what? Volume is going to be area, that is pi r square, times height. Surface area, if I talk about, surface area is going to be what? It's going to be 2 circles. So it's going to be 2 pi r square and that curved surface. So plus 2 pi r h. And if we talk about cone, so for cone, it's going to be what? So volume is going to be 1/3 of the volume of cone, that is pi r square h. And if we talk about surface area is going to be how much? It's going to be, the base is a circle, that's why pi r square plus pi rl. Just remember, this is thoda tricky, this pi rl, where L is the slant height, and you can use Pythagoras theorem for finding radius and height, whatever it is. Now, after this, we talked about sphere. So sphere is going to be what? Sphere is area is going to be, surface area is going to be 4 pi r square and volume is going to be 4 by 3 pi r cube. Now, the thing is, the tip is that I'm comparing perimeter, area and volume. Now, perimeter is what? Length of the thread, which we have discussed earlier. So we always calculate that in meter, centimeter, like that. Area is meter square and volume is meter cube. Now remember, all these formulae will be based on these units. So for example, by chance, I thought that, volume of the sphere is 4 pi r square. If I think about it, then I'll just see whether my units are getting satisfied there or not. So if I talk about volume, volume is always in meter cube, right here. But here if I see pi is a constant, radius square it is. So that's why my answer is coming in meter square, which is absolutely wrong. I had to get meter cube. That's why my formula is wrong. So it's going to be 4 by 3 pi r cube. Same goes with circle. For circle, sometimes we feel that circumference is pi r square and area is 2 pi r. But we'll just see which units are getting satisfied. So here only one radius is there. That's why here it is in meters. Here it is in meter square. So it's absolutely wrong. That area is not in meters, it is in meter square. Circumference is in meters, but here it is in meter square. So you can verify that for each and every formula whenever you write it. So let's see. See, for example, here it's meter cube because pi is a constant. So here it's going to be meter cube. That's why sphere will be in meter cube. Here, here it is very important. See, cone is what? Volume. If we are talking about volume is what? Meter cube. Radius is in meter square. Height is in meter. So at the end, I'm getting meter cube. That's why my answer is right. Here, if I talk about surface area, be it lateral or total surface area, if you see here, it's pi r square. So again, this is in meter square. And pi rl, this is also in meter square plus meter square, which will give me meter square eventually. That's why my answer is right. Now, similarly for cylinder, if you see volume, meter square into h, that's why it will give me meter cube. If you talk about surface area, now what is happening here? So as I told you, don't use this formula, use the above formula. So here it's meter square, like this thing is in meter square. RH is also into meter, that's why meter square. So at the end, my answer is in meter square. So as you can see here also it's meter square, that's why I have verified. Beat lateral surface area also, see here meter square, that's why it gets verified. Similarly for cube also, definitely it's meter cube, here it's meter square. Similarly here also meter square, meter square, meter square, at the end I'll get meter square as the answer. So that's why my total surface area is fine. For volume, meter into meter into meter, that's why meter cube. So never get confused. And also if we talk about previously, which we have talked about this circle and all, so that time also whenever they ask you area, so again you can verify triangle is base into height. So that's why meter into meter, again meter square. So that's why it's area. So remember, always concentrate on unit. Now this is my tip which you can use anytime for any problem. If you like this video, please like it, comment it, and share as much as possible. It will motivate me to work more on these topics or these kind of videos. So please help me. Thank you so much.